Hi, and welcome to Reaction Rates. Today we are going to talk about what reaction rates are and how we can manipulate a reaction to go faster or slower. Reactions and time. Reactions take place over a period of time. Some of you might think that it happens instantaneously, but some reactions happen slow, some reactions happen very quickly. Things that happen very fast, examples of that would be anything that explodes or burns. TNT, for example, is a reaction that happens very, very fast. When we light a stick of dynamite, if we are doing some mining, it blows up. Reaction happens very, very fast. Burning propane is also an example of something that happens very, very fast. A reaction rate that takes place over a longer period of time would be rusting. It happens very slowly. Let's talk about what a rate is. Rate is anything that happens over time. There are other types of rates, but for our discussions today, we're going to look at just rates of time. An example would be the distance traveled compared to the time it took you to travel. That distance would be a speed. So we can have a rate of speed. Reactions occur over time is a reaction rate, or rate of reaction. It's essentially how fast does the reaction take place. There's 5 things that we can do to affect the reaction rate. 1 is manipulate the temperature. 2 is change the surface area of the reactants or of the reactants. 3 would be stirring. If we have a solution, stirring will help it go faster. We can also manipulate the concentration of the reactants, or we can add a catalyst. In order for particles to react, they must come into contact with each other. You can think of the particles as being bumper cars, and they cannot react until they collide into each other. The more bumper cars we have on the track, the more times they will run into each other. The faster they go, the more times they'll run into each other, and the better chance they'll have to react. Temperature. If you remember back to the kinetic theory of particles, temperature is a measurement of the kinetic energy, which has to do with how fast the particles are moving. The warmer something is, the faster the particles move. More motion is going to mean there are more collisions. Heating something up means a faster reaction rate will take place. We can also manipulate the surface area. The more area particles have to hit each other on a surface, the faster the reaction takes place. If we have a bunch of small particles, we have more surface area than if we have the same amount of mass in one big particle. There's more area for it to get to. The next thing we can look at is mechanical stirring. Whenever we stir something, we increase the exposure of the particles to each other, and thus will increase the number of collisions. Concentration. The more particles we have in the same area means more collisions, which means more chance of them hitting each other and reacting. If we go back to our bumper car example, the more bumper cars we have on the track, the better chance that they will hit each other. A catalyst. A catalyst is a substance that can affect the reaction but doesn't actually take place. It facilitates or speeds up the reaction or reduces the temperatures at which the reaction needs to take place. Catalysts are all around us. They're even in us. If you think about the burning of sugar, that requires a lot of heat in order to cause that combustion reaction to start. However, our bodies at a much lower temperature are able to burn sugar for our energy needs because of the enzymes in our cells, which are catalysts. It will lower the energy barrier, and when we write the catalyst in a reaction, we actually write it above the arrow.